All right, so we're going to look at some problems with quadratic equations, and to start, we're going to look at a little bit of physics. So in physics, the height of a projectile at any given time can be modeled by the equation h equals 1/2 times gravity times time squared minus the initial velocity times time plus the initial height. So h is the height that we find at the time t, and then h naught is our starting height, v naught is our initial velocity, and g is the acceleration due to gravity. Most of the questions we'll be doing will take place near the surface of the Earth, where gravity measures out at about negative 9.8 meters per second. So it accelerates towards the ground at negative 9.8 meters per second. And my mistake, that is an acceleration. That should be meters per second squared. So make sure you put that square in there. Thus, if we were to take that formula and modify it to work for on situations where we're dealing with things on Earth, in general, it will be the height at any given time is equal to negative 4.9 times that time squared plus the initial velocity times the time plus the initial starting height. So let's take a look at an example of using this. We want to create a quadratic model of a ball thrown upwards at a velocity of 10 meters per second from a height of 1.5 meters. We want to use the model to determine both the maximum height of the ball and how long it's in the air. So we got a little equation here. We got a little that we can make, and we can get a little sketch of what's going on first. So it's going to be all positive situation here, but we're starting at about 1.5 meters above the ground. We're shooting up at 10 meters per second, and so it's going up and it's coming down. And we got something looking like this. We got some non-existent things here. This is time, this is height. And velocity of 10 meters per second, that is the height over, or the distance over the time. So there's our velocity graph, height versus time. And we want to use the model to determine both the maximum height of the ball and how long it is in the air. So if we want to find the maximum height of the ball, we want to find the vertex. And if we want to find how long it's in the air, we need to find the zeros. So we got to find the zeros and we got to find the vertex. Those are the points we're going to be looking for. Well, let's start with an equation. So h equals negative 4.9 t squared plus the initial velocity was 10, so 10t. Our initial height was 1.5. The initial height portion makes sense because that's our c value, that's our starting height. Because the only real thing here that's different is just throwing in that gravity, throwing in that velocity. So there is our equation. Now we want to know the vertex. We want to know how long the ball's in the air. Well, our vertex, we can use the x equals, or in this case, t equals negative b over 2a. We can use that to find the t value of the vertex, and then we can use that to find the maximum height. So t equals negative 10 over 2 times negative 4.9. 2 times negative 4.9 is going to be negative 10 over negative 9.8. And so when we divide 10 by 9.8, we're going to get 1.02 approximately. So our time of the maximum height is positive 1.02 seconds. So that's when we hit maximum height. And so now to find the specific height, we go height equals negative 4.9 times 1.02 squared plus 10 times 1.02 plus 1.5. And now we calculate that, and we got negative 4.9 times 1.02 squared plus 10 times 1.02 plus that's a 1.5 there at the end, 1.5. And we get approximately 6.6 So our max height is about 6.6 meters. And now the other part that we have to do is find when it hits the ground, because we want to know how long it was in the air, so we need to find that time that it hits the ground at. So that we'll use our quadratic equation. So we have t equals negative b, so negative 10 plus or minus the square root of 10 squared minus 4 times negative 4.9 times 1.5. Divide that by 2 times negative 4.9. So t equals negative 10 plus or minus. And then our square root of that all is 10 squared, 10 times 10 minus 4 times negative 4.9 times 1.5. The square root of 129.4 over negative 9.8. And then we just have 10 plus the square root of 129.4 over negative 9.8, or time equals 10 minus the square root of 129.4 over negative 9.8. I didn't leave myself a lot of room here. But what we'll do here is calculate these. Negative 10 plus the square root of 129.4. And we divide that by negative 9.8. So that's going to give us t equals negative 0.14. That one's not going to be admissible because we can't have negative time in our situation. And then we have negative 10 minus the square root of 129.4 divided by negative 9.8. And that's going to give us approximately 2.18. So it hits the ground after about 2.18 seconds. So therefore, max height is 6.6 meters. I'm not leaving myself any room here. And hits ground at 2.18 seconds. Okay, so jam that in there. But there is my situation there. So I found the max height by finding the vertex, so the axis of symmetry, sub in to find the vertex, and then use the quadratic equation to find the times. And now, some more problems. Product of two consecutive even numbers is 528. What are the numbers? So in a situation like this, consecutive even numbers, we don't know the numbers. You can solve this by trial and error. Good on you if you want to spend your time trial and erroring a whole bunch of numbers. However, instead of wasting your time on extra calculations, well, what if I try? Why don't we find the exact two numbers? By quickly using the quadratic equation, because 528 equals a number, one even number is x, and then the next even number is x plus 2. So if I expand this out, I got 528 equals x squared plus 2x. And then 0 equals x squared plus 2x minus 528. There's my equation. Sub that into the quadratic equation. We have negative 2 plus or minus the square root of positive b squared minus 4 times a times c all over 2 times a. So there's our equation. x equals negative 2 plus or minus the square root of. Calculating inside there, we have 4 plus 4 times 528. Square root of 2116 over 2. Negative 2 plus or minus the square root of, or sorry, well, let's actually calculate the square root of 2116. So that's 46 over 2. So we got x equals negative 2 plus 46 over 2, or x equals negative 2 minus 46 over 2. And when we do that, we have negative 2 plus 46 equals divided by 2. So x equals 22, or x equals negative 24. Now you're probably saying, wait a minute, that doesn't work. 22 and 24 aren't consecutive even numbers. Those are separate. They're not side by side. It's positive and negative. It's because there's two possible sets of answers. So your trial and error, you will probably get 22 and 24. So one set is 22 and 24, because 22 times 24 is 528, but you won't get the negative. You won't likely remember to get the negative set. So we now have the positive set 22 and 24, x and x plus 2, or else negative 24, and the next number would be x plus 2, would be negative 22. There we have all possible solutions to this equation. So normally your trial and error would get you this, and you get the positive numbers, and that's good, but it's not enough anymore, because we now know that there are two possible situations that could work. Even numbers could be positive or they could be negative. We often forget about that, but now working with our square roots, knowing that they're positive and negative, you should make sure you remember that. One more. So here we got a right angle triangle. One leg of it is 4 centimeters longer than the other leg, and the hypotenuse is 8 centimeters longer than the short leg. What are the three side lengths? So we got this right angle triangle. I'm just going to do a quick little sketch here. So we got a hypotenuse of 8 centimeters longer than the short leg. So that is, well, let's start with this short leg. Short leg here, this would be my short leg down here, it's x. And then the other leg is 4 centimeters longer, so that's x plus 4. And then the hypotenuse is x plus 8. So there's my three side lengths. Now, how do these all relate? Well, this is a right angle triangle. And what do we know about right angle triangles? How do the three sides relate to each other? Well, through the Pythagorean Theorem. So the short side squared, x squared, plus the other short leg, x plus 4 squared, equals the hypotenuse squared. So I have x squared plus, and if we FOIL this out, we'll get x squared plus, and that's a perfect square trinomial. So we'll have 8x plus 16. And this side here, we'll have x squared and another perfect square trinomial plus 16x plus 64. Let's take all this and solve for x by collecting like terms and such. So we have 2x squareds, and then we're going to move that one over. So we get x squared plus x squared minus x squared. When we move that x squared over, we have a plus 8x here. We got a minus 16x, and then we got a 16, and then a minus 64. So, or sorry, not equals 16 minus 64. We have a plus 16 minus 64, and that's going to end up equaling 0. Let's collect all these. So this is just going to leave us with x squared. This is going to leave us with negative 8x, and this is going to leave us with negative 48. And so now we need to solve this two numbers that multiply to 48 and add to 8. What do we got? 12 and 4. 12 and 4, we could have negative 12 and positive 4. So x squared plus 12x, or sorry, minus 12x. Minus 12x plus 4x minus 48. And yes, you could use the quadratic equation here, but we don't need to. I mean, I can do this pretty quickly without it because I have x minus 12 plus 4, x minus 12 equals 0. So x plus 4 and then x minus 12 equals 0. So I got x equals negative 4 or x equals positive 12 when I finish solving that. So there are my possible answers. However, can we have a negative 4 for a side length? No. So this one is inadmissible. That's inadmissible. Therefore, the sides are 12. 12 plus 4 is going to be 16. And then 12 plus 8 is going to be 20. So those are my three sides. So there's some solving some problems with quadratic equations.